Have you ever felt sand slip between your fingers? Did you know that every grain has a story? An entire branch of physics dedicated to understanding them? Today, we'll explore the incredible, mind-boggling physics of sand and learn why these tiny grains are more fascinating than you ever imagined. Buckle up, folks, because this is science at its most granular. Let's dive in. First, let's talk about what sand actually is. Sand is made up of particles, each measuring between 0.06 and 2 millimeters in diameter. Most commonly, sand consists of quartz, a silica-based mineral, but it can also be made of other materials like shell fragments, volcanic glass, or even coral. Sand may seem mundane, but it makes up the world's deserts, beaches, and riverbeds. Beyond scenery, sand plays essential roles in construction, technology, and even climate regulation. So yeah, there's a lot more to sand than meets the eye. Now, let's get into the physics of it. The science of sand falls under the study of granular materials, which are neither fully solid nor fully liquid. Granular materials have unique properties that have puzzled scientists for centuries. Let's start with one. How does sand behave under pressure? Say you're trying to stand on a beach. Sand beneath your feet compresses, creating a stable surface. But have you noticed that if you pick up speed or jump, you sink deeper? This phenomenon illustrates something called the jamming transition, where grains of sand rearrange under force. This ability to shift between solid-like and liquid-like behavior makes granular material an enigma in physics. But here's where it gets even cooler: quicksand. Quicksand might seem like something out of an old adventure movie, but it's rooted in real physics. Quicksand occurs when water saturates sand beyond its capacity, reducing the friction between grains. This creates a fascinating, albeit dangerous, situation where sand behaves like a liquid that traps you. Fear not. Getting out of quicksand is more about staying calm and spreading your weight evenly than any dramatic struggle. The science behind quicksand teaches us how unrestricted water flow can dramatically alter the behavior of granular materials. Speaking of water, let's examine how sand interacts with it. Ever built a sandcastle? If so, you've noticed that damp sand holds together, whereas dry sand doesn't. This is due to something called capillary action. Small amounts of water form tiny bridges between grains, creating surface tension that acts as glue. Capillary action is the same principle behind how plants transport water from their roots to leaves. This unique interplay between sand and water is why coasts and beaches present such stunning yet scientifically complex landscapes. Another jaw-dropping phenomenon is the ability of sand to flow like a liquid. Have you ever been mesmerized by an hourglass? The sand flows at a steady rate, even though it's made of irregularly shaped particles. How does this happen? The answer lies in something called percolation theory. This theory explains how spaces between the grains allow air to move, reducing friction and letting the grains flow in a near-liquid manner. It's like nature's way of creating an elegant timer. Then there's the science of dunes. Sand dunes are much more than just picturesque mounds. They're dynamic systems that move, grow, and even sing. Wind carries sand particles up the slope, but gravity pulls them down, creating different shapes depending on the speed and direction of the wind. But have you heard of singing dunes? Certain dunes emit a low-frequency hum when sand grains slide against each other under specific conditions. Scientists believe this happens due to synchronized vibrations among the grains. Just imagine, the desert has its own music. How poetic yet scientific. Let's shift gears to something less poetic but equally transformative: human use of sand. Did you know that sand is one of the world's most consumed natural resources? It's the key ingredient in concrete, glass, and silicon, which is used to make the computer chips powering your devices. Yet not all sand is equal. Desert sand, like that in the Sahara, is too smooth for construction uses. The gritty sand in riverbeds and beaches is much more valuable in industries. With increasing demand, we're now facing a sand crisis. Yes, you heard that right. A sand crisis. Sustainable management of this resource has become an urgent global need. And let's not forget the ecological side of sand. Sand is home to countless organisms, from crabs to microorganisms. Its role in ecosystems underscores why preserving sand-based environments is so vital. In scientific terms, the porosity of sand determines its ability to host life and filter water. Incredible, isn't it? These little grains are unsung heroes of the natural world. But wait, we still have to address one last mystery. Why is sand often hot during the day and cool at night? This is due to its low thermal conductivity. Sand heats up quickly under the sun, but cools down just as fast once the sun sets. This dual behavior affects the climate of deserts, creating massive temperature swings from day to night. Understanding this phenomenon is helping researchers develop better thermal insulation materials for buildings. So, there you have it, the extraordinary physics of sand. From grain structure to jamming transitions, quicksand mysteries to singing dunes, sand is so much more than mere dirt. It's a building block of nature and civilization, a playground for the curious and a puzzle for scientists. Next time you're on a beach, take a moment to marvel at this overlooked wonder of our world. Consider the thousands, if not millions of years it took to shape those tiny grains under your feet. Thank you for tuning in to this episode of Scientific Facts. If you found this fascinating, don't forget to like and share this video. And as always, stay curious and keep questioning the world around you.